Hi everyone, my name is Xiaoyu Tongyang, and welcome to the series videos of my final project. In this series video, I will introduce my final project as well as one application of my final project, which is the application of the triangulation algorithm. So for the outline of this series video, first I will introduce my final project, including introductions, motivation, and approaches I used to implement. And then I will talk about the demo of my final project. And the rest of the videos are about the application. So first, I will briefly introduce the application and then go through an example and then go through an example of the final algorithm. This algorithm is the core of the application, core algorithm of the application. Last but not least, I will discuss the time complexity of the application to see how fast is the overall algorithm. So first, let me introduce my final project. In summary, my final project aims at animating the triangulation algorithm we learned in class step by step. So we will have two parts of the algorithm to visualize. The first one is partitioning monotone polygons, and then the triangulation algorithm. In other words, my final project will visualize those two algorithms as well as their pursuit code. Lastly, I will introduce one application of the final project, that is, find the shortest path in a simple polygon with the triangulation algorithm as preprocessing step. As for the motivation, in the class we know triangle is very important in the field of computer graphics because triangles has very nice properties such as convexity. So in most cases, we will usually triangulate concave polygons into triangles in order to avoid many problems that concave polygons may have. And I will talk about this more detailedly in the rest of the videos. And the overview of my final project is, I mentioned before, to visualize the two algorithms, partitioning monotone polygon and triangulation, as well as their pursuit code. But there is one assumption with my final project, that is, the input polygons are all simple. So we can't input complex polygons. And what are the complex polygons? So we look at these two examples. The first one is the polygons with self-intersected vertex. As you can see here, we have a self-intersected vertex. So you can see in this vertex as two vertex overlapping each other, and this one is a complex polygon, not a simple one. Also, a polygon with holes are not simple. This one. In other words, the inside of the polygon is this area. In other words, this and this is outside of the polygon. And you can see this area is the whole of the polygon, and this polygon is not simple. And this is the assumption of my final project. As for the approaches I used to implement, first, this is a web-based web page with JavaScript and WebGL. I use WebGL for visualization and animation. By the way, the animation technique I used is simply the linear interpolation I learned in animation algorithm class. This animation technique is very simple to implement, and as we can see in the rest of the video or in the demo, this linear interpolation is quite enough for the animation. In other words, we don't need other complex interpolation algorithms. And I think the most interesting point of my final project is to implement the feature that you can draw next and draw previous animation and switch between each other in the way you want. The way I did it is to take advantage of the concept of snapshot. So in other words, in the process of the triangulation, or in the algorithm, I will store each snapshot for the status for each status of the algorithm, and I will store drawing data for vertex and triangle and the sweep line and also those diagonals. So each time I will draw a snapshot on the canvas to show the result to the users. The way I do it is to initialize two stacks, and as you can see, one is current stack and the other is next stack. So we will initially we will push all snapshots into the next stack in this way. And when you draw next animation, you pop a snapshot from the next vertex and push it onto current stack, and always draw the snapshot on the top of the current stack. This picture shows what I said. So in the contrast, when you draw previous animation, you pop a snapshot from the current stack and pop and pushed onto the next stack, and also always draw the one on the top of the current stack. In this way, you can switch between next and previous animation. Lastly, we will need to utilize a JavaScript promise class in order to animate in certain order, like we want to first draw a sweep line and then polygon and diagonals and so on. And this is a technique detail. As for the related work, this final project is an individual work, so the only member is me. And as for the demo, I will talk over my final project web page with a few examples to illustrate on my demo. So I will talk about this in the next video. Okay, thank you.